Hey there. We are going to be talking about decomposing fractions into partial fractions. This is part A of a three-part series with an optional part at the end for some extra practice problems. So here we go. So this is our 5-4 objective here, partial fractions. So essentially what we're going to be doing is taking some rational expression, you can see an example of one below, and we're going to be decomposing or pulling it apart into its initial, fix that right there, initial polynomial factors. So let's look at how we can do this, what's this going to look like, and what our end goal might be. So step one is going to be take a look at some sort of rational expression, and we want to just begin by factoring the denominator. So this is a quadratic that we're very familiar with factoring. So we're going to leave our numerator alone and simply factor this denominator into an x minus 5 and an x plus 2. Okay, that's all there is to step one. Okay. Step two, we are going to take this rational expression with a factored denominator, and we are going to write one partial fraction for each factor where our numerators are constants. We're going to let those constants be a and b because we only have two factors. We would use c, d, etc. if we had more factors. Okay, so what is this going to look like? So we're going to set this equal to constant a divided by our first factor, x plus 5, plus a constant b divided by our second factor, x minus 2. All right, and that's it for step two. Okay, so where do we go from here? Too far ahead. The next thing we want to do, step three, is we want to solve eventually for a and b, but our denominators are in the way. It's difficult for us to solve with denominators. So we're going to go kind of back to the last objective, which was solving rational equations. And we're going to do something very similar, which is multiply through by the least common denominator in order to cancel out our denominators and be able to solve. So if I'm looking at that, our least common denominator here is going to be x minus 5, x plus 2, and I have to do that on both sides. So on both sides, I'm going to multiply through by x minus 5 and x plus 2 there. Okay, so on the right-hand side, left-hand side, excuse me, that just nicely cancels out, and we are simply left with 6x minus 2. And then on the right-hand side, something slightly different happens. So this is basically created a distribution problem, and we need to take that least common denominator and multiply it to both terms inside our brackets. So when we multiply it by our first term, we can see that our x minus 5s will cancel out there, and we will be left simply with a times x plus 2. And then for our second term, this time our x plus 2s are going to cancel out, and we'll be left with b times x minus 5. Okay, now this is getting a little bit nicer and looking like we can maybe do some things to solve for a and b, those constants. All right. So the next thing, so how can we find those? We do want to find these constants, and we're going to find them using the zeros of our two factors. So if we look at our two factors here, x plus 2 and x minus 5, well, this first factor, x plus 2, is going to become 0 when x equals negative 2. And this second factor, x minus 5, well, this is going to be 0 when x equals positive 5. So let's use that. So let's go ahead and let's solve first for A. Okay, so let's solve for A. Well, in order to do that, I would really like the other term, the one with B, to equal 0. And the way we're going to do that is we're going to let x equal 5, the 0 of that factor. Okay, so when we do that, what do we get? So everywhere I see an x, I'm going to substitute in a 5. So on the left-hand side, we're going to get 28. And on the right-hand side, we're going to get a times 7. And then that second part there is just 0. So we don't need to worry about writing that. We're going to finish this off, solve for a. And we're going to go ahead and get that 4 equals a. Let's do very similar solve for b. So this time I want to find b. So this time I want the other guy to be 0. So let's let x equal -2. So this time everywhere I see an x, we're going to substitute in a -2. So we'll get -14 equals b times -7. Finish solving, and we'll get 2 equals b. So now we have these constants, and we can go all the way back and substitute these into that initial part where we wrote our, too far. So we're going to write this out. So we're going to say, hey, this original 6x minus 2 rational expression divided by x squared minus 3x minus 10, we said this was equal to some constant a, which we just found out is 4, divided by x minus 5, plus some constant b, which we just said was 2, divided by x plus 2. All right, that is our final answer. But let's check and make sure that this works. So what I'm claiming is that if I actually add these together, right, these two kind of smaller rational expressions, I should end up back at my original rational expression, right? All I did is take the original and pull it apart into two smaller pieces. So let's just double check that. We go back a slide here, we can see, hey, we added those two partial fractions. Yes, we did in fact get back to partial fractions, which we did that. So I'm going to take these, 4 divided by x minus 5 plus 2 divided by x plus 2, and we're going to go ahead and do this addition. So we need common denominator, so I'm going to multiply this guy by x minus 5 over x minus 5. We're going to multiply this guy, this first guy, by x plus 2 over x plus 2. Normally when we do that, we don't bother distributing in the denominator because we want to leave it as factored as possible. Because we're trying to just check our answer, I am going to distribute. So one thing I'm going to do is put these in parentheses though. Okay, because we are doing a distribution problem. All right, so we should end up with a 4x plus 8 divided by, let's see, x squared minus 3x minus 10. Oop, that's starting to look familiar. Okay, plus 2x minus 10 divided by x squared minus 3x minus 10. All right, so already, if you look back at our original rational expression that we started with, we've already got that denominator. So let's see what happens when we add together our numerators. So we have a common denominator, so we can just add or combine like terms up there in our numerator. We'll get 6x minus 2 divided by x squared minus 3x minus 10. Well, good. That's what we wanted. So what we started with. So we know we did it correctly, and we're all good to go. So this is our first introductory part of decomposing rational expressions into partial fractions, and we will go ahead and kick it up a notch from here.